Good morning students. In the last class we have seen time scaling operation for continuous time signals. Now we will see one example for discrete time signals. Okay. So let's take this question. Sketch the following signals for the signal x of n equal to 2, 3, 1, 2, 1. This is a given signal in the form of sequence. Okay. And we have to sketch x of 2n, x of n by 2, x of minus 2n, x of minus n by 2. Okay, so for better understanding, so I am plotting the signal in the graphical form. So we know that this arrow mark indicates the origin value. So it's minus 1, minus 2, 1, 2. Okay, minus 1, minus 2, 0, 1, 2. So maximum amplitude is 3, 1, 2, 3. This is x of n. Okay, at origin its value is 1, at minus 1, 3, at minus 2, 2, and at 1, at 2, its value is 1. Okay, so now we are going to perform x of 2n, x of n by 2, x of minus 2n and x of minus n by 2. So before starting this problem, first we should remember that in discrete time signals, signal present at only discrete intervals of time, that is the n values are 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. Okay, that is, these are called samples. Okay, so samples present at only discrete intervals. Okay, so while dividing, so we know that in time scaling operation we have to divide the limits by a value. Okay, so while dividing the limits, so here samples, dividing the samples, if we got any decimal value for n, for example if I divide minus 1 by 2, so I got minus 0.5, right? So similarly if I get decimal values of n, so we should discard the entire sample. Okay, so only for values 0, plus or minus 1, plus or minus 2, we have to plot the signal. Okay, so I hope this will be clear after performing these operations. Okay, so first we'll see x of 2n. So we know that y of n is equal to x of an. This is a representation of time scaling operation in discrete time signals. Okay, so first case x of 2n. Okay, so I'm going to plot directly by dividing the limits by a. So here the a value is 2. So if I divide the limits by a means 0 by 2, 0. Okay, so this sample will present minus 1 by 2, minus 0.5. So we should discard the sample. Minus 2 by 2, minus 1. So this sample gets moved to minus 1 position. Okay, so we'll draw first. X of 2n, 0, minus n. So minus, if I dividing the limits by 2 means 0 by 2, 0. So the sample will present. So at 0 its value is 1. Minus 1 by 2, minus 0.5. So we should not plot the signal for decimal values of n. So we should discard the sample. And minus 2 by 2, minus 1. So this sample will move to minus 1 position. So at minus 2 its value is 2. So this is moved to minus 1 position. Okay, in positive side 1 by 2 means 0.5, and so similarly we should not consider the sample, and 2 by 2, 1. So this sample will get moved to 1 position. So at 1 its value is 1. Okay, for minus 1 and 1, while dividing 2 we got decimal values, so we have to discard the sample. For minus 2 and 2, if I divide, I'll get minus 1 1. So this samples will get moved to minus 1 and 1 positions. Okay, this we can prove mathematically. So y of n equal to x of 2n, right? So if I substitute n equal to 0, y of 0 equal to x of 2 into 0, 0. So x of 0, so x of 0 is 1. Okay, and if I substitute n is equal to minus 1, so 2 into minus 1, x of minus 2. Okay, so x of minus 2 equal to 2. If I substitute minus 2, okay, so x of 2 into minus 2, minus 4. So in the given signal at n equal to minus 4, no signal is present, so x of minus 4 is 0. So even if I compute y of minus 3 means here it will come x of minus 6. So after that we don't have any signal, so we can stop here itself. Okay, so we'll compute for positive side. So n equal to 1. 1 means 2 into 1, 1. So x of 2. X of 2 value is 1. And if n equal to 2, y of 2. So 2 into 2, 4. X of 4. Here the signal stops at 2 itself. So x of 4 equal to 0. Okay. So if y of 3 equal to x of 6. So x of 6 also not present. So we can stop here itself. Okay. So if you check with the signal, y of 0. Y of 0 is 1. Okay. Y of minus 1 equal to 2. Y of minus 2 is 0. So after y of minus 3, y of minus 4, everything will be 0. Okay. So y of 1 is 1 and y of 2 is 0, and similarly y of 3, y of 4, everything will be 0. Okay. So we can directly divide the limit by a value. If we get the decimal values of n, we can discard the sample and only the integers we have to plot. Okay. So in the examination, you can directly draw x of 2n from x of n. Okay. For better understanding, I have proved this. Okay. So similarly, we will calculate x of n by 2. Okay. X of n by 2. So here a value is 1 by 2, right? So 1 by 2 means if I divide the limits by 1 by 2, it's equal to multiplying the limits by 2. Okay. So if I multiply the limits means 0 into 2, 0. Minus 1 into 2, minus 2. So this sample will get moved to minus 2 position. And minus 2 into 2, minus 4. So this sample will get moved to minus 4 position. So in minus 1 and minus 3, we don't have any samples. Okay. Similarly, this sample will get moved to 2 position and this sample will get moved to 4 position. And 1 and 3, we don't have any samples. Okay. So we can draw x of n by 2. One, two, three, n minus n. Okay. So if I multiply the limit by 2, because here n by 2. Okay. So if I dividing the limits by 2 means it's equal to multiplying the limits by 2. Also I have mentioned the last class itself, whenever we got the template like n by a means we can directly multiply the a value. So here the division means we have to multiply with the limit. So here the multiplication means we have to divide. Okay. So 0 into 2, 0. So at 0 its value is 1 and minus 1 into 2, minus 2. So this sample will get moved to minus 2 position. and minus 2 into 2 minus 4, and this sample will get moved to minus 4 position. Okay, so at minus 1 and minus 3 we don't have any signal, it is 0. Okay, and 1 into 2, so it's moved to 2 position. 2 into 2 4. At 1 and 3 we don't have any signal. Okay, so this also we can prove mathematically, that is y of n equal to x of n by 2. So if I substitute n equal to 0, y of 0 means x of 0 by 2 0. So x of 0 equal to 1, and y of minus 1 equal to x of minus 1 by 2, that is x of minus 0.5. So here no signal present at x of minus 0.5, so its value is 0. And y of minus 2 equal to x of minus 2 by 2, that is x of minus 1. Minus at x of minus 1 value is 3. Okay, and next y of minus 3 equal to x of minus 3 by 2, that is minus 1.5. At minus 1.5 we don't have any signal, so y of minus 3 is 0. Y of minus 4 equal to minus 4 by 2, x of minus 2. So x of minus 2 equal to 2. Okay, and if I calculate y of minus 5 means x of minus 5 by 2, so it's equal to x of minus 2.5. So after minus 2 we don't have any signal, so we can stop here itself. So we'll move to positive side. So y of 1 equal to x of 1 by 2, that is x of 0.5. At 0.5 we don't have any signal, and y of 2 equal to x of 2 by 2, it's equal to x of 1. So at x of 1 its value is 2, and y of 3 equal to x of 3 by 2, which is equal to x of 1.5. At 1.5 we don't have any signal, and y of 4 equal to x of 4 by 2, which is equal to x of 2, and x of 2 equal to 1. Okay, so after x of 2 we don't have any signal, so we can stop here itself. So now we will check with the resultant signal. So y of 0 is 1. Okay, and next y of minus 1 is 0, y of minus 2 is 3, and y of minus 3 is 0, and y of minus 4 is 2, y of 1 is 0, y of 2 is 2, and y of 3 is 0, and y of 4 is 1. Okay, so this is how we have to perform x of n by 2. Okay, that is, if when we got the template like n by a, we have to multiply the limits by a value. When we get the template like x of an, we have to divide. While dividing, if we get the decimal values of n, we have to discard the sample. So only for integer values we have to plot. Okay, so next we will see x of minus 2n. X of minus 2n. So as we discussed in the previous class, so in this operation we have to perform time reversal as well as time scaling. Okay, so first we need to plot x of minus n. After that we have to divide the limits by 2 in the signal x of minus n, as we did in the continuous time signal. Okay, so first we have to plot x of minus n. So this is x of n, and we know that the signal present at 1 and 2 will get shifted to minus 1 and minus 2 respectively, and the signal present at minus 1 and minus 2 will move to 1 and 2 respectively. Okay, so we can draw x of minus n as N, 2, 3, and At 0 it won't be changed. 1 minus 1 3, so it will get moved to plus 1. Okay, and at minus 2 it's 2, so it gets moves to plus 2, and at 1 its value is 2, so it will move to minus 1 position. At 2 its value is 1, so it will be moved to plus 1 position. Okay, now we have to perform time scaling operation, that is x of minus 2n. Okay, so here a value is 2, so we have to divide the samples by 2. So if I divide, automatically we have to discard the samples minus 1 and 1, because if I divide by 2, here we will get minus 0.5, so here I will get 0.5. Okay, so we have to discard the samples. So if I divide minus 2 and 2, we will get minus 1 and 1. So these samples will get moved to minus 1 and 1 positions. Okay, so I will get x of minus 2n like this. At 0 its value is 1. At minus 1, so this sample will get moved to minus 1 position, so this value is 1, and at n equal to 1 it's 2. Okay, so for x of minus 2n, first we have to perform time reversal operation, that is we have to plot x of minus n, and then we have to perform time scaling operation. So we have to divide the samples by 2. So while dividing, we have to discard minus 1 on 1 samples, and we'll get only samples minus 2 and 2. So dividing by 2, so it's moved to minus 1 and 1 position. Okay, so now we will perform x of minus n by 2 operation. Okay, so x of minus n by 2. So in this case also we have to perform time reversal as well as time scaling operation. So we need to plot x of minus n first. So already we have plotted x of minus n. So after that we have to divide the limits by 1 by 2. So dividing 1 by 2 equal to multiplying by 2. So if I multiply the limits by 2 means we will get, so we should be careful that if time reversal operation is there, we have to refer only x of minus n, not x of n. Okay, so here students will make mistakes. Okay, x of minus n by 2. Okay, so if I multiply, so we have to refer x of minus n for x of minus n by 2. Okay, so if I multiply 0 by 2 means 0 only, the same sample. If I multiply minus 1 into 2, minus 2, so this sample will get moved to minus 2 position. So at minus 2 its value is 2. Minus 2 into 2 minus 4, so this sample will get moved to minus 4 position. At minus 1 and minus 3 its value is 0, and then 1 into 2 2, so this gets shifted to 2 position. At 2 its value is 3. 2 into 2 4, so at 4 its value is 4. Okay, at 1 and 3 its value is 0. Okay, so now if you compare x of 2n and x of minus 2n, x of 2n and x of minus 2n, so it's a time reversed signal, that is x of 2n is the mirror image of x of minus 2n. Okay, so number of samples are same. Okay, and then if you see x of n by 2 and x of minus n by 2, it's a time reversed signal. Okay, so x of n by 2 is the time mirror image of x of minus n by 2, and the number of samples also equal. Okay, so and one more thing, if you see with x of n and x of 2n, the number of samples gets reduced, that is In x of n, we have 5 samples. In x of 2n is only 3 samples. So number of samples gets reduced when a value is greater than 1. Okay, and number of sample gets increased when a value is less than 1. That you can understand if you compare x of n and x of n by 2. Okay, so whenever a is greater than 1, modulus of a is greater than 1, number of samples gets decreased. So it's called downsampling or decimation in time. So this terms you will study in digital signal processing. Okay, and whenever modulus of a less than 1, okay, so number of samples gets increased. Okay, so it's called upsampling or interpolation. Okay, so in continuous, so we are referred as compressed signal and expanded signal. So in discrete, we have to refer it as downsampling when a is greater than 1 and upsampling when a is less than 1, or downsampling or decimation, upsampling or interpolation. Okay, so here also this upsampling and downsampling depends only on the magnitude value of a, not on the sign of a. Okay, so because in x of 2n, x of minus 2n, we have only 3 samples. Okay, so only difference is the time reversed signal. Okay, and similarly x of n by 2 and x of minus n by 2, we have similar number of samples, that is more number of samples. Okay, so this upsampling and downsampling depends on the magnitude value of a. Okay, so this is a time scaling operation of discrete time signals. So if you have any doubt, you can mention in the comment. Thank you. In the next class, we will see summary of all the basic operations. Okay, thank you.